Hello, everyone. You have tuned in to episode 58 of the Our Weekly Highlights podcast. This is the podcast where we take a deeper dive into the highlighted stories from the current week's issue on ourweekly.org. Today, we are covering the issue highlights for issue 2021-38, released on September 20th, 2021. And this week's issue is curated by John Calder, with help from the Our Weekly team members and contributors. A great way to jumpstart learning or strengthening skills in data science is finding a topic or question that resonates with you. Thanks to an abundance of interesting data sets, there's no shortage of great areas to pursue. Some of these data sets are nicely curated as part of a larger initiative like Tidy Tuesday, while others require a little more rolling up your sleeves to perform some data extraction, perhaps through undocumented APIs or web scraping. One particular domain that has always garnered interest from fans and analysts alike is television, a rather timely topic as the 73rd Emmy Awards took place this weekend here in the United States. Certainly how we consume what is traditionally labeled as television has evolved considerably, with the advent of streaming services, and the shows themselves often have their own unique paths to continue to adapt for drawing larger ratings and general buzz amongst media and advertising. In the 1990s, the genre of reality television, which we could have a whole separate podcast covering that topic alone, became mainstream in the world of television, especially shows that augmented game and sports-like competition with a little hints of drama here and there. The Music Television Network, more commonly known as MTV, was near the forefront of reality TV programming with shows like The Real World and Road Rules. In 1998, they created a spin-off show called The Challenge, which took previous cast members from these aforementioned shows to compete in team-based missions, all for winning a big cash prize at the end. The show is still going strong today, and it is in the midst of its 37th season, which is quite a run if I do say so myself. In light of the evolving cast and overall themes presented in the show's lifespan, how can modern data science and modeling techniques reveal similarities or differences amongst these seasons? That's a question Joshua Lawrence addresses in his blog called JLog's Blog for our first highlight today. I've mentioned before that ideally we would have elegant and simple methods to obtain rich data sets online via transparent APIs, but we do not have one for the challenge seasons, and I better not hold my breath for one to be created. But Josh was able to leverage the Wikipedia entries of the overall show and individual seasons to employ the RVest package along with selected Tidyverse packages to assemble a dataset of all cast members per season. Like any scraping project, and I can attest to this from a recent project of my own, not everything goes according to plan, and Josh had to build various logic checks to account for variation on the structure of season pages and even inconsistencies on how some cast members are labeled when they were present in multiple seasons. With the data in hand, Josh performed some quick exploratory data analyses to uncover insights such as how Johnny Bananas de Venanzio has been on a whopping 20 seasons of that show, and how the seasons with the largest pools of contestants tend to have more of the one and done, meaning cast members that don't return for subsequent seasons. Next, Josh employs a few different methods of unsupervised learning, which is a class of methods in which the prediction is not so much the main focus, but instead the idea is to discover patterns about the features or whatever the measured characteristics are of the source data, and to uncover natural groupings or clusters, just to name an example. Josh creates a network graph powered by Thomas Peterson's ggraph package to demonstrate how early seasons exhibit unique groupings, while the remaining seasons show robust connections via the cosine similarity metric. turning to a traditional hierarchical clustering analysis based on deriving a wide distance matrix of each cast member as a column and the individual seasons as rows, that revealed a set of 5 groups that apparently make logical sense according to his knowledge of the show. When I said a wide distance matrix, this was indeed a wide set due to the 360 columns corresponding to all the possible cast members. But this was a great chance to perform dimension reduction via the UMAP algorithm, which is an alternative to the more commonly known principal component analysis. Interestingly enough, the clusters resulting from the UMAP method are indeed similar to the ones that he obtained from hierarchical clustering. All of the code in Josh's analysis is present in his blog, and I really enjoyed it for many reasons, one of which is that I too am embarking on a scraping and modeling project that has to do with media content, and ironically, a post that he had linked to in the introduction of this current post looked at how he was able to scrape ratings data of Wednesday night cable television, which was another great example of text extraction in action, and I happened to be following one of the shows that ended up in the top 3. Maybe you'll be hearing more about that later. But sure enough, this is a great way to show another example of the end-to-end process of taking an interesting data set that resonates with yourself and generating an insightful analysis out of it for, in this case, all the world to see. I often catch myself a few times in a week or even a day saying in my head that I wish R could solve all my computing needs. Sometimes I feel like we get closer to that vision thanks to the rich ecosystem of packages wrapping a multitude of open source software, such as APIs and powerful libraries in different languages. Sometimes the path to these external libraries is like a smooth paved road, and the path is unlocked with a simple library call to a new package and using their clearly documented functions. But there are situations where we have to travel off-road and navigate the system utilities that only have the tried and true command line waiting for input with no wrappers in sight. If you find yourself in that situation, the latest blog post, authored by our OpenSci's own Yaron Ooms and former R Weekly curator Mael Salmon, gives you a great view of the options available in these situations for our last highlight today. Thus far, I've been pretty vague about the potentially rough expedition you might find yourself in when utilizing the command line programs directly from R, and this post paints a picture for you. Unlike most situations where all the processing of native R functions are performed in the same system process as R itself, every call out to a command line utility from R launches a new system process that is isolated in more ways than one. Specifically, you can't share anything with that process call other than strings that are translated to the command and optional arguments. Given the variability in what inputs and outputs these command line interfaces offer, the onus is on you to deal with the potential errors and exceptions that can occur. Also, what you get back won't be a traditional R object, but simply the exit code of the command line utility, typically in an integer, and the stream of output text that comes without friendly formatting. Many of the packages in the R ecosystem that expose system utilities are based on other languages, such as C++, Python, or JavaScript, where we have packages to help with the translation of input and output. Again, that's the ideal situation, so it's advantageous to do a bit of searching first if you're curious if a command line utility has an R wrapper already. But the picture is not so gloom if these packages are simply not available for a given utility. While the included system and system2 functions can be efficient for smaller scale command line interfaces, there are 2 packages available to take command line calls to a higher level. First, the sys package, offered by Yaron avoids the text piping of inputs and output streams by creating in-memory pipes, as well as the ability to return binary form output if desired, which can be more efficient in certain situations than just obtaining a bunch of text output. With that said, if you find yourself wanting to launch multiple system calls as separate processes, then the Process X package, authored by RStudio software engineer Gabor Sardi, may fit the bill. In this package, you're able to launch a number of processes in the background and have elegant methods based on the unique class structure to interrogate their status and perhaps even do more complicated chaining and event-driven operations. I can vouch for this being an important package in some of the work I do, where a wrapper on top of that called call-r by the same author I use routinely in, for example, my complicated Shiny apps to launch a background process, keeping the main thread of the R and Shiny interface ready for the user to manipulate with while this background process does its magic. I highly recommend bookmarking this post if you find yourself in a situation where you are forced, or perhaps by choice, using a command line utility that simply hasn't been packaged up in a nice way yet. There is a lot to learn about how to use these effective packages for your situation. Another highly recommended read. And those are your R Weekly highlights for today. John has another jam-packed issue for us to enjoy, with additional stories such as generating what are called climate circles for visualization, a very cool tip on obtaining signed Git commits with Keybase and RStudio, a new package for creating interactive web exercises with R Markdown, and much more. And I certainly hope this podcast is another way for you to enjoy the wonderful content of R Weekly and certainly the innovations of the R community. And if you're enjoying this, my only ask would be to leave a nice positive review on the podcasting platform of your choice, such as Apple Podcasts or wherever else you get your podcasts from, as that greatly helps discoverability. Have a fantastic week, and we will be back with another batch of our weekly highlights next week.